A delta breaker is a type of molded case circuit breaker that is designed to provide protection for electrical circuits in both normal and emergency situations. It is typically used in industrial and commercial applications where reliable circuit protection is essential. Delta breakers are generally rated for higher currents and voltages than regular breakers. Also, they have a trip mechanism designed to trip the breaker quickly and reliably in the event of a fault or overload. Regular breakers are designed to provide protection for electrical circuits from overload and short circuits. They are typically used in residential and commercial applications where the demand for power is lower. Regular breakers are rated for lower currents and voltages than delta breakers. Thus, they may not be able to provide the same level of protection in the event of a fault or overload. The key differences between delta breakers and regular breakers include current rating, voltage rating, trip mechanism, and application. Firstly, delta breakers are rated for higher currents than regular breakers. That makes them suitable for applications with higher power demands. Secondly, delta breakers are also rated for higher voltages than regular breakers. That allows them to protect circuits that operate at higher voltages. Thirdly, delta breakers typically have a faster trip mechanism than regular breakers. This ensures that the breaker trips quickly in the event of a fault or overload. Finally, delta breakers are typically used in industrial and commercial applications, whereas regular breakers are used in residential and commercial applications. A molded case circuit breaker, or MCCB, is a type of electrical protection device that is used to protect electrical circuits from overcurrents, which include both overloads and short circuits. These are commonly used in industrial and commercial settings where high current and voltage levels are present. MCCBs are designed to provide a higher level of protection compared to standard circuit breakers and are typically rated for currents ranging from 15 amps to 2500 amps. They are available in a variety of voltage ratings, up to 600 volts or higher. The main function of an MCCB is to interrupt the flow of current when an overcurrent condition is detected. This is achieved through a thermal magnetic trip unit, which consists of two main components. The thermal component responds to overload currents, while the magnetic component responds to short circuit currents. When an overload occurs, the thermal element heats up and causes the breaker to trip. In the event of a short circuit, the magnetic element quickly trips the breaker to minimize damage to the electrical system. MCCBs are also equipped with a manual trip mechanism, which allows the breaker to be manually opened for maintenance or safety purposes. This feature is important for isolating circuits during repairs or when working on electrical equipment. In addition to their overcurrent protection capabilities, MCCBs can also provide other features such as ground fault protection and arc fault protection. Ground fault protection is designed to detect and interrupt ground faults, which can occur when current leaks to ground. Arc fault protection is designed to detect and interrupt arc faults, which are dangerous electrical discharges that can cause fires. When selecting an MCCB for a specific application, it is important to consider several factors, including the voltage and current requirements of the circuit, the interrupting capacity of the breaker, and the desired level of protection. The interrupting capacity is the maximum current that the breaker can safely interrupt without being damaged. It is important to choose a breaker with an interrupting capacity that is greater than the maximum fault current that could occur in the circuit. Overall, molded case circuit breakers are an essential component of modern electrical systems, providing reliable protection against overcurrents and other electrical hazards. Their robust design and advanced features make them well suited for use in a wide range of applications, from industrial plants to commercial buildings. Circuit breakers, in general, are crucial components of electrical systems, designed to protect circuits from damage caused by overloads or short circuits. They function as automatic switches that interrupt the flow of electricity when a fault is detected, preventing damage to equipment and reducing the risk of electrical fires. There are several types of circuit breakers, each with its own specific characteristics and applications. Miniature circuit breakers, or MCBs, are commonly used in residential and light commercial applications. They are relatively small in size and are designed to protect individual circuits within a building. MCB typically have current ratings of up to 100 amps and are available in a variety of tripping characteristics such as B, C, and D curves. The tripping characteristic determines the speed at which the breaker will trip in response to an overcurrent. Molded case circuit breakers, as discussed earlier, are used in higher current applications typically ranging from 15 amps to 2500 amps. They are designed to provide a higher level of protection compared to MCB and are commonly used in industrial and commercial settings. MCCBs are available with a variety of features, such as adjustable trip settings, ground fault protection, and arc fault protection. Air circuit breakers, or ACBs, are used in high current applications typically ranging from 800 amps to 6300 amps. They are designed to protect main distribution circuits in large industrial and commercial facilities. ACB use air as the insulating medium to extinguish the arc that occurs when the breaker trips. They are available with a variety of features, such as microprocessor-based trip units, zone-selective interlocking, and communication capabilities. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. They work by detecting small imbalances in the current flowing through a circuit and tripping the breaker if a ground fault is detected. GFCIs are commonly used in wet locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or AFSIs, are designed to protect against electrical fires caused by arc faults. They work by detecting the unique characteristics of arc faults and tripping the breaker if an arc fault is detected. AFSIs are commonly used in residential bedrooms and other areas where there is a high risk of fire. When selecting a circuit breaker for a specific application, it is important to consider several factors, including the voltage and current requirements of the circuit, the interrupting capacity of the breaker, and the desired level of protection. The interrupting capacity is the maximum current that the breaker can safely interrupt without being damaged. It is important to choose a breaker with an interrupting capacity that is greater than the maximum fault current that could occur in the circuit. Circuit breakers are essential components of electrical systems, providing reliable protection against overcurrents, ground faults, and arc faults. Their proper selection and installation are critical for ensuring the safety and reliability of electrical systems. Delta breakers are specifically designed for three-phase electrical systems, often found in industrial settings. These systems utilize three separate alternating current sources to deliver power more efficiently than single-phase systems. Delta configurations, one of the common types of three-phase systems, do not have a neutral wire. Instead, the three phases are connected in a closed loop, resembling the Greek letter delta. This arrangement provides several advantages in high-power applications. One of the primary benefits of a delta system is its ability to handle unbalanced loads more effectively than other three-phase configurations. In an unbalanced load scenario, the current draw on each phase is not equal. Delta systems can redistribute current between phases, minimizing voltage imbalances and ensuring more stable operation of connected equipment. Delta breakers are designed to protect these three-phase circuits from overcurrents and short circuits. They differ from standard single-phase breakers in several key aspects. Firstly, delta breakers are typically rated for higher voltages and currents, reflecting the demands of industrial equipment. Secondly, they incorporate sophisticated tripping mechanisms that respond quickly to faults in any of the three phases. This rapid response is crucial for preventing damage to expensive machinery and minimizing downtime. Furthermore, delta breakers are often equipped with additional features, such as adjustable trip settings and ground fault protection. Adjustable trip settings allow technicians to fine-tune the breaker's sensitivity to overcurrents, optimizing protection for specific equipment. Ground fault protection detects current leakage to ground, which can indicate insulation failure and pose a safety hazard. By interrupting this circuit in the event of a ground fault, the delta breaker prevents electrical shock and reduces the risk of fire. In contrast, regular breakers are primarily designed for single-phase circuits, commonly found in residential and light commercial settings. These breakers protect against overloads and short circuits in individual circuits, such as lighting, appliances, and outlets. Regular breakers are typically rated for lower voltages and currents than delta breakers. Their tripping mechanisms are simpler, designed to respond to overcurrents in a single phase. While regular breakers provide essential protection for everyday electrical needs, they are not suitable for the high power demands and complex fault conditions encountered in three-phase industrial systems. Selecting the appropriate type of breaker is crucial for ensuring the safety and reliability of an electrical system. Using a regular breaker in a three-phase delta system would be inadequate and could lead to equipment damage or even fire. Conversely, using a delta breaker in a single-phase circuit would be overkill and unnecessarily expensive. Consulting with a qualified electrician is essential for determining the correct breaker type and size for any electrical application. A qualified electrician can assess the specific requirements of the circuit, taking into account factors such as voltage, current, load type, and environmental conditions. They can then recommend the most appropriate breaker to provide optimal protection and ensure compliance with electrical codes. In addition to selecting the correct breaker type, proper installation and maintenance are also crucial for ensuring its reliable operation. Circuit breakers should be installed in accordance with manufacturer's instructions and local electrical codes. Regular inspections should be performed to check for signs of damage or wear. Breakers should be tested periodically to verify their tripping function. Any faulty breaker should be replaced immediately to prevent potential hazards. Understanding the differences between delta breakers and regular breakers is essential for anyone working with electrical systems. Delta breakers are specifically designed for three-phase industrial applications, while regular breakers are intended for single-phase residential and commercial use. Selecting the appropriate breaker type and ensuring its proper installation and maintenance are crucial for protecting equipment, preventing electrical hazards, and maintaining the overall safety of electrical systems. Electrical panels house the circuit breakers that protect your home's wiring from overloads. They are essential components of any electrical system, ensuring safety and preventing damage from excessive current flow. Understanding the various parts of an electrical panel and their functions is crucial for homeowners to maintain a safe and efficient electrical system. The main breaker is the primary shut-off switch for all power entering the panel. In an emergency, or when performing electrical work, switching off the main breaker cuts off power to the entire house. Branch circuit breakers protect individual circuits in your home, such as lighting circuits, appliance circuits, and outlet circuits. When a circuit is overloaded, the corresponding breaker trips, interrupting the flow of electricity and preventing damage to the wiring. Bus bars are metal strips inside the panel that distribute power from the main breaker to the individual branch circuit breakers. They provide a common connection point for all the breakers and ensure that each circuit receives the correct voltage and current. Neutral bar is a terminal strip where all the neutral wires from the circuits connect. It provides a return path for the electrical current and is grounded to ensure safety. Ground bar is a terminal strip where all the ground wires from the circuits connect. It provides a path for stray electrical current to flow safely to the ground, protecting against electrical shock. The panel enclosure is the metal box that houses all the components of the electrical panel. It provides protection from physical damage and prevents accidental contact with live electrical parts. A circuit directory is a label or chart that identifies each circuit breaker in the area or appliance it controls. It is essential for quickly locating and resetting trip breakers. When a circuit breaker trips, it is important to identify the cause of the overload before resetting it. Common causes of trip breakers include overloading a circuit with too many appliances, a short circuit in an appliance or wiring, or a ground fault. If you are unsure about the cause of the trip breaker, it is best to consult with a qualified electrician. It is important to never replace a circuit breaker with one of a higher amperage rating. This can overload the wiring and create a fire hazard. Circuit breakers should be replaced with the same amperage rating as the original breaker. Regular maintenance of your electrical panel can help prevent problems and ensure its safe operation. This includes keeping the panel clean and free of debris, checking for loose connections, and testing the circuit breakers periodically. If you notice any signs of damage or problems with your electrical panel, it is important to consult with a qualified electrician. Working with electricity can be dangerous, and it is always best to leave electrical work to the professionals. Understanding the various components of an electrical panel and their functions is essential for homeowners to maintain a safe and efficient electrical system. Regular maintenance and prompt repairs can help prevent problems and ensure the reliable operation of your electrical system.